Good day, one and all. Welcome to the second part for lecture number 5 of the course IE 306 Supply Chain and Logistics Management. This is a lecture that is dedicated to one of the most important forecasting methods, the linear regression analysis. And this method can be used to determine forecasts when the demand has a level as well as a trend component. So this is not a method that is ideal for a case where we see seasonality in demand. So for any demand pattern or any sales data pattern where you observe only level as well as a trend in demand, then this method is a good choice. So we'll talk about linear regression analysis to both for use of both estimating the values or initial estimates of LNT as well as for forecasting demand. I am Matthew Baby, Assistant Professor with the Department of Mechanical Engineering, Rajagiri School of Engineering and Technology. So without further delay, let's get started. So by the term regression, we mean finding a relation between variables. So whenever we are talking about linear regression, we are assuming that the relation between the variables is linear. That means when one of the variable varies, the other varies in a directly proportional manner. So any form of method where we try and relate two variables or two or more variables by using an equation or by representing the relation between two or more variables in the form of an equation, we call that method as a regression. When only two variables are related, we call it a simple regression. And when we are relating more than two variables, we call it a multiple regression. Now, for forecasting, we take the case of, or we are trying to assess or find the relationship between a demand as well as time. So we relate the variation of demand as a function of time. And this relation is basically assumed to be linear, and that is why it's basically a simple regression of the linear form, and that is why it is termed as linear regression. Okay, and there is a generic method. We'll discuss about two methods, method 1 and method 2. Method 1 being a modification of method 2. The method 2 is a generic form of linear regression which can be used for forecasting demand as well as ascertaining the or estimating the initial values of level L0 and trend T0. These are level values and trend values at time t is equal to 0. So estimation of initial values of level and trend can be done. Along with that, the forecasting of demand can be done by using method 2, which we'll be discussing in detail in the coming slides. But method 1 is a specialized form or a modified form of method 2, which is a generic form, and this is used only for forecasting demand. So in linear regression, what we do is we plot a graph between demand, that is on the y-axis, and time on the x-axis. Okay, so we plot it as a function, or we plot the demand as a function of time. So as time passes, for each time interval, say x, for every value of x, we'll plot what the corresponding demand is. So these points, they show the variation of demand as time progresses. So the actual relation is not purely linear. Okay, but what we are trying to do is we are trying to approximate this particular relation into a linear one, and this linear approximation is what we call, this linear approximation is a straight line, and it is of the form, the straight line equation is of the form y is equal to a plus bx, where a is a y-intercept when we extrapolate the linear line or the linear regression line onto the y-axis. So the point where the linear approximation of the relation between demand and time period, when we extrapolate that particular linear approximation, the point at which it meets the y-axis That is nothing but the demand at time t is equal to 0. So that particular value is represented as A, and B is nothing but the slope of this particular linear approximation. So you get a relation of the form y is equal to a plus bx, where a is a y-intercept at time t is equal to 0 and b is a slope of the line. So when we look at it from the forecasting viewpoint, the value of y is nothing but the forecast. Okay, the rigorous forecast, the forecast where we are trying to predict. The value of a is nothing but the level value at L time t is equal to 0. Okay, so this is the demand at time t is equal to 0, which we call as initial estimate of level L0. So the value of a is nothing but L0. The value of b is the slope of this line, and that indicates the trend. Okay, that is the actual amount by which the demand varies from one time period to the next. That is the slope of this particular line indicated by b. So the trend estimate t is nothing but b. So we are basically drawing an approximate linear relation, and this approximation is by using of a theory called sum of residuals, least sum of residual squares. Okay, by the residual I mean the difference between the actual demand at a particular point of time, okay, and the linear approximation at that particular point of time. So if we draw this particular solid linear line as a approximation or linear approximation of demand with time, then there is always an offset, a vertical offset or a vertical displacement from the actual demand to the linear approximation. So this particular difference between the actual demand at a particular point of time to and the the demand at the linear approximation, that particular value is what we call as residual. So this particular vertical distance, okay, this is yi, this is the actual demand minus the calculated demand, which is nothing but from the linear regression, from the linear approximation. So this particular value is called as a residual. Now some of the residuals are positive, some of the residuals are negative. Okay, we find such a line such that the sum of these residuals, sum of the squares of the residuals specifically, okay, so this particular value is called as a residual. So some are positive, some are negative. So it should be such that the sum of the residuals should be 0, or the residual squares, so sum of the residual squares should be as minimum as possible. So that is how we determine the slope of this particular line. Okay, so the line is drawn such that the sum of the squares of the residual is kept minimum. So this particular line, in order to keep it at a particular keep the residual square, sum of the residual squares minimum, it will have a particular slope. Okay, so that will determine its slope, and based upon its slope, the point at which that particular linear approximation meets the y-axis, that is nothing but the y-intercept, will also have a specific value. So we do not randomly draw this particular horizontal or this line or this linear trend line, but it is such that the sum of the squares of the residual is minimum. Okay, and in order to do that, we can actually calculate the values of a, that is a y-intercept, and b using the given set of data. Okay, so in method 1, as I told you, this is the modified form of the generic method, that's method 2. This is only used for forecasting demand, and this considers the central time period of the given historical data as time t is equal to 0. Okay, so it is not the time or it is not the time period of the first time period before the first data period that is given in the historical data that is considered t is equal to 0, but rather from among the given historical data, okay, we take the central time period as time t is equal to 0. So this is basically a modification of the original one. We'll see the original method or the generic method in the coming slides. And we fit a straight line, okay, in the linear regression method, and this straight line is given by the equation y is equal to a plus bx, where y is a dependent variable, which is nothing but the regress demand forecast, and x is the independent variable, okay, which we can vary independently, and it is in terms of units of time. And a is the initial estimate of level L0, and b is the estimate of trend t. So b is nothing but the slope and a is the intercept. In the graph, when we look at a and b, a is nothing but the y-intercept and b is the slope of the line. Okay, so this particular, if we want to ascertain the values of a and b, okay, in this particular equation for linear regression, y is equal to a plus bx. If we want to predict what the demand would be at a particular point of time x, okay, x is a independent variable which is expressed in terms of units of time, okay, and y is the actual regress demand forecast. We need the values for us to predict what the demand would be using the linear regression. We want the values of a and b, okay, and this particular values of a and b, that is nothing but the y-intercept value and the slope, is basically found out by solving two equations, simultaneous equations called normal equations. Okay, so by using these two normal equations, when we solve this, we'll get the value of a as nothing but the sum of the y terms. Okay, by y I mean the demand terms. So whatever demand that is given, sum it up, divided by the number of time periods. Okay, so a is nothing but the average of demand. Okay, so sum of the values of demand, okay, divided by the number of time periods over which you are given the demand data, you will get the value of a, which is nothing but the average of demand, and b, which is a slope which corresponds to the trend estimate, is taken as sum of product of x and y. Xy stands for product of time and demand. Okay, so xy, sum of xy divided by sum of x square, that is square of the time periods. So when you sum up, when you calculate this particular value, you will get the value of b, that is the estimate of trend t. Okay, so to understand this better, we'll have a look at two different examples. So in the first example, that is example A, you are given the actual sales in thousands of units, which is indicated by the variable y, okay, as different years passes. So different years, from when we move 2001, 2002 to 2007, we see that the actual sales, okay, this is not 80, this is actually 80,000. So they are in thousands of units. So we see the time is given in years. So for each year, the actual sales is given over here. We are supposed to calculate, or we are supposed to find out a linear regression equation relating the actual sales quantity and the time period. So since in regression, okay, we are not going to use these values of time period 2001, these are years. What we're going to do is, we are going to, in this method number one, we are going to find out which is a central time period. For that, we have to first of all assess how many number of time periods of data is given to you. So in terms of number of values of x, so we have values from 2001 to 2007. So you have 1, 2, 3, 4, 5, 6, 7, 7 time periods of data for 7 time periods given to you. So the value of capital N, which is nothing but the number of time periods of data given to you, that is odd, that is 7. And in order to calculate this particular value of a and b, you can use the equations which you get from solving the normal equations, sigma x, sigma y by n and sigma xy by x square. So here the value of x used is nothing but not these 2001 values, but rather you use the deviation of the value of time period from the central time period. So in this particular set of given data, you can see that out of this particular 7 sets of values, the centralmost time period is 2004. So we calculate the deviation of the time period from 2004. Okay, so 2001 minus 2004 is minus 3. 2004 to 2002. From 2002 to 2004, you are moving back. 2004, you are moving back 2 years to 2002. So you get the values of x as time deviation from the mean value, okay, of the given time period. So since these are the years given, the mean value is at 2004. So the deviation of the period 2004 from 2004 is 0. And any time period behind that will have a negative value, and in front of that will have a positive value. Okay. So here the variable of time is represented as time deviation from the mean value of given data. Okay, so given time data, you find that 2004 is the mean value, and the deviation of the period from 2004 is indicated as x. So when we move behind or move to a time period that is ahead of the mean time period, then by ahead I mean prior to the mean time period, we'll have a negative value. Okay, and for any value that is after the time mean period, it will have a positive value. Okay, so you have to represent these values like this. X values are x represented like this, and y are nothing but the actual sales values. Okay, so just copy these down, then you can square these x value. Okay, square of time. So you have x square values over here in this particular column. So you have 941019149. Okay, so those are x square values, and this is nothing but the product xy. Okay, you have to multiply column number 1, sorry, column number 2 and column number 3, the values of corresponding rows in column number 1 and 2 and 3. Okay, so minus 3 into 80, you have minus 240. So write down those values, and at the bottom you write the sum values. Okay, so sigma x is nothing but the sum of x values, which is always 0. Okay, in method number 1, the sum of x values will always be 0. Capital N is nothing but the number of time periods. So here we have 7 time periods. Sigma y, sum these different these values in these different columns. Okay, sorry, this particular different rows in this particular column. Sum these values up, you will get sigma x square, and sum these values up, you will get sigma xy. So since you know sigma xy, sigma x square, sigma y and n, you can calculate the value of a and b. So a, according to the equation, okay, for method number 1, we take it as sigma y by n. Okay, this is specific for method number 1. Okay, we'll see how we have arrived at these values from the generic method equations later on. Okay, so for value of a, we take it as sigma y by n. Sigma y is 630 divided by n is the number of time periods that's observed, that is 7, you get 90. And the value of b is sigma xy by sigma x square, which is 56 by 28. So you have 2. Okay, so you can see that whenever we move into a time period that is just before the mean time period, your product xy values will always be negative because the time values are negative. Okay, and after that you will have positive values. So when you take up the sum, okay, it can be either positive or negative here. Okay, depending upon which is bigger. Mostly it will be positive in most cases. It need not be always positive, it depends upon how the demand varies. So this value sigma xy can be positive or negative. So a negative value b indicates that, a negative value of sigma xy indicates that the trend is declining. That means as time progresses, the average demand is decreasing. So if you have a negative xy value, then your value of b will also be negative because your sigma xy by sigma x square values will never be negative. Okay, so if b is negative, that means sigma xy is negative, and a negative value of b indicates that the trend is negative or declining. Okay, so and if the value is positive, that means after each subsequent time period, the demand has a trend of increasing values. Okay, so since you have a is 90 and b is 20, you have a regression equation that comes to a form y is equal to 90 plus 2x. Okay, in order to predict the demand for the next time period, say 2008, you have to just substitute the value of x corresponding to 2008. So since we are calculating the value of x as a deviation from the central time period in our consideration is 2004. So from 2004 to 2008, we have moved 4 time periods ahead. That's why the value of x, okay, for y is equal to 2008, the value of x will be 4. Okay, so substitute the value of x corresponding to the time period you want the demand to be forecasted. You will get your actual demand. So this is only purely used for forecasting demand, not for ascertaining the values of initial values of L and T. So this is the regression equation as I told you for the previous example. And for 2008, you just have to substitute the value of x, which is nothing but the time deviation from the mean value of time period, that is 2004. So from 2004 to 2008, you have moved plus 4 time period. That's why you use x as 4. and you substitute here 90 plus 2 into 4, 98. Okay, that means thousands of units. 2009, you just substitute the next value of x. So from 2004 to 2009 you have moved plus 5 time periods, so you substitute the value plus 5. Okay, so 90 plus 10 you have 100,000 units. So this is a very simple method. As I told you, this can only be used under the situation where a demand is observed to have only level and trend. Okay, any seasonal fluctuations in demand, it requires us to deseasonalize the demand data to use this particular method. Okay, so for demand data that has seasonality, this is not the apt method. The best method for that would be the Winters model. Okay, so we have already discussed the Winters model in the previous lecture. So use that particular method when your demand data has seasonality, trend, as well as a level component. Okay, so we'll have a look at example number B. So just like the previous case, we have the actual sales data in lakhs. This is in rupees, not in terms of quantity, over 6 time periods. From 2002 to 2007, you have 6 time periods. So capital N is 6, which is even. Now in this particular case, it is very difficult for us to find an exact central time period. Okay, so the central time period somewhere falls between somewhere 2004 and 2005. So we take the central time period as 2004.5, and the x values here are taken as 2 times or twice the deviation from the central time period. So if we take the deviation from the central time period 2004.5, we'll to 2004 you have moved back minus 0.5 years. So this particular fraction or decimal multiplication is quite complicated. So what we do is we replace that decimal values, or in order to avoid a decimal value, what we do is we multiply those particular values by 2. So x values are nothing but 2 times the time deviation from the mean time period, and in this particular case it is 2004.5. So from 2004.5 to 2004 we have moved back 0.5 years. Okay, so 0.5 multiplied by 2 will give you minus 1. From 2004.5 to 2003 you have moved back minus 1.5 years, multiplied by 2 will give you minus 3. So the values of x are computed as such. Okay, so you won't have a value of x where x is equal to 0, because there is no exact central time period, since the number of time periods given here is even. Okay, n is equal to 6 in this particular case. So again, sigma x, when you sum it up, you'll always get 0 here. Okay, and this, as I told you in this particular method number 1, we assume the central time period as time t is equal to 0. Okay, x indicates the value of time period t. So we are assuming not the very first time period as time t is equal to 0, we are assuming the central time period as time t is equal to 0. So that is why this method is different and cannot be used for estimating initial values of level and trend. Okay, so sigma x is equal to 0. This is the actual value of sales, okay, in terms of in terms of amount, in terms of rupees. Sigma y, then x square values, just square these values, you can write it down, sigma x square, and sum of these up, take the product of these values xy and sum these up, you get a sigma xy which is positive. And as I told you, sigma xy which is positive, that indicates that your slope value b will be positive, and that will indicate a increasing trend. So here when you calculate the value of a, you get a as 120 and b as 4. That means since b is positive, again is an increasing trend. So using this regression equation, you can forecast the demand for the next time period. So for example, the demand for 2008, that is y 2008, is calculated as 120 plus 4 times the value of x here will be calculated differently. It will not be 6, because when we move from 2004.5 to 2008, we have moved 3.5 years. Okay, that is plus 3.5 years, and when you double it, you will get 7. Okay, so what you have to do is, if the number of time periods is even, okay, if it is even, then the values of subsequent time periods, that is x, will change by 2. Okay, so if we move from 2007 to 8, the value of x in 2007 was 5, in 2008 it will become 7. If the value of n was odd, like 7 in the previous case, then from one time period to the next, the value of x would only vary by 1 unit. Okay, So using the regression equation that we developed in the previous slide, okay, the value of x is measured as 2 times the numerical difference between the given time period and the mean time period of the given data. So for 2008 we have moved plus 3.5 years. When you multiply that by twice, 2 times, you get 7. So for 2008 you will use the value of x as 7. 2009 you will use it as 2000. Sorry, for 2009 you will use the value of x as 9. So therefore you can see that between two consecutive time periods, the value of x increases by 2 when the value of n, that is number of time periods data that is given, it is even. Okay, so this is the very first method. It's a very simple method to use. So this method, that's method number 1, is a, as I told you, a modified form of method 2 that we'll be discussing in the coming slides. Okay, so method number 2 is nothing but a generic form, and this is basically a modified form. And I repeat once again, method number 1 should only be used purely for forecasting demand. It should not be used for estimating the initial values of level as well as trend. Okay, L0 and T, you cannot use this particular equation because we are assuming the central time period to be T is equal to 0 and not the first time period in the given set of data. Okay, so we have to consider the next method, that's method number 2, which is the generic form of linear regression. So in method number 2, it's basically the generic form of linear regression, and this can be used for forecasting demand as well as for estimating initial values of level L0 as well as trend T0. Okay, for Hall's method as well as for Hall's and Winters models. For both kinds of models, you have to estimate the initial values of trend and level. So L0 and T0 has to be estimated for Hall's and Winters model, which are both adaptive models. Okay, and for initially estimating the initial values of level and trend, that is L0 and T0, you have to use this particular generic form of linear regression, which will be discussed right now. So the relation between the variables, that is the demand as well as time, will remain the same. It will be of the form y is equal to a plus bx, where a is a y-intercept which will give you an estimate of level value at time t is equal to 0, and b will give you the slope of the line, which is also an estimate of trend. Okay, so a is the level value and b is a trend, and to calculate b you have to know n is nothing but the number of time periods. Okay, just like in the previous model, n is the number of time periods, sigma xy, where x is the x is the time and y is the actual demand, minus sigma x into sigma y, that is sum of x values into sum of y values, divided by n times sigma of x square. So sum of the x square values minus sum of x values squared. This will give you the value of slope. Okay, and just substitute the value of uh, this particular b in this equation to get the value of a, that is a y-intercept, which is nothing but an estimate of level, initial level L0. Okay, so it is nothing but sigma y minus b by sigma x by n. Okay, if you think about this, if you split this particular denominator value into these two halves, you will get sigma y by n minus b by sigma x by n, and sigma y by n is nothing but y bar, which is the average of y values, minus b times sigma x by n will give you the average of x values. So it's y bar. Alternatively, it can be written as, okay, when you expand this particular equation, you can write it as a is equal to sigma y by n minus b times sigma x by n. Okay, when you think about this, y by n is nothing but y bar is the average of y values, minus b by sigma x by n is nothing but x bar. Okay, so it's y bar minus bx bar. That's a simple form. Now, if you think about this, when you take the value of x bar and y bar, okay, when you talk about x bar value, the average value of x, okay, in the case of method 1, the average value of x, when you sum up sigma x, would be this particular term in method number 1, sigma x is always 0. Okay, so therefore this particular term would come to 0, and what you have is a is equal to y bar. This is the equation that we see in the method number 1. Okay, the value of a. Okay, similarly the value of b will also be different. When you simplify this particular equation, you will get to a form that is similar to the previous one, okay, that we saw in method number 1. So using this particular equations, you will get the value of a and b, and then you can use that particular linear regression equation to forecast demand as well as to estimate the initial values of level and trend. So we'll have a look at an example for this method number 2, which is the generic method. You are given the actual sales during 8 time periods, okay, over 8 months, and you are asked to forecast the demand for the 9th and 10th month using linear regression. So you either use the previous method, because here you are asked to forecast the demand. So you can use method number 1 or method number 2. So using method number 2, we'll have a look at how we'll solve this. Okay, so the number of observation periods, number of time periods given, capital N is equal to 8. The sum values are also given over here, okay, corresponding to each of the columns. So the sum of the month datas. So here x values are not the deviation of the central time period, rather they are taken as the time periods itself. That is a major difference between method number 1 and method number 2. Okay, instead of taking x values as a deviation from the central or mean time period, we are taking the time periods as such. Okay, so that's why this is called as generic method, and method number 1 is basically a modification of this particular method, okay, where we take x values as a difference or deviation from the central time period. So here, since n is even, okay, in method number 1 we would have taken the central time period as between 4 and 5 as 4.5. In this particular case, in method number 2, we do not have to do that. Okay, so sum of the values of x, the actual sales values, okay, this is sigma y, 279 is sigma y, x square values are given over here. So square these values, sum them up, you will get x square, sum sigma x square. Square the sales values, sum them up, you will get sigma y square, and multiply x and y, you can write it down over here, and sum them up, you will get the sigma xy values. Okay, let's substitute over here. B is nothing but n times, which is n is 8 times sigma xy, which is 1154, minus sigma x minus sigma y, which is sigma x is this one, 36, times sigma y, that is sum of sales is 279, divided by, okay, n times sigma x square. So it's sum of x square values. Okay, sigma x square is 204. So 8 times 204 minus sigma x the whole square. So sigma x is sum of the x values, which is 36. The whole square is 36 square. So when you solve it, you get 7.11 as the value of b. Okay, nothing but the slope. Okay, and value of a, you get it as y bar minus b by minus b times x bar, or when you substitute it, 279, which is y, sigma y, minus b is 7.11, which we have calculated over here, times the value of sigma x is 36. So 36 divided by capital N is the number of time periods, that is 8. So we get value 2.89. Okay, so this is a regression equation that we have, which is y is equal to a plus bx, where a is 2.89 and b is 7.11 times x. So since b is positive, again the demand has an increasing trend. So using this particular regression equation, you can predict the demand for the 9th as well as 10th time. That was the question. So for the 9th time period, you have to just put the value of x as 9. Okay, for the 10th time period, you have to put the value of x as 10, because we haven't done any modification to the x value, like in method number 1, where we have chosen the central time period, okay, or the mean time period, and taken the value of x as a deviation from the central time period. So there is no such modification in this particular method number 2, which is a generic form of linear regression. You just put the value of the actual time period for which you want the demand to be forecasted as x. So we want Y for the period 10, that is the forecasted demand for period 10, so nothing but 2.89, which is the initial estimate of level plus the trend value, where 7.11 times the time period 10, 73.99 or approximately 74 units. Okay, so this is how you actually do linear regression. So preferably I would like the students to learn method number 2, that is a generic form, okay, which has a wider range or wider scope of application, because it can be used for both forecast and demand as well as for estimating initial values of L and T, which are required for the Halls as well as the Winters model for forecasting. So the Winters and the Halls model requires initial estimates of L and T, and this can be done only by using linear regression. For the Winters model specifically, we have to first of all de-seasonalize the demand data. Winters model is used for demand data that has seasonality as well. So we have to de-seasonalize the demand data and then carry out linear regression to estimate the initial values of L and T. Okay. With this, I conclude this lecture. Thank you.